Part B is nothing really new. It's just a comment. This is what we will need in, starting in the next session. I really recommend that you revise the notion of differentiability classes, differentiable maps on, from Rn to Rn. This could have been like from Rn to Rm, but let's make it simple to just Rn to Rn, right? So from undergrad, I don't know, a lot of you, I'm pretty sure most all of you, if not most of you, already have at least undergrad calculus or multivariate calculus thing in the past. Okay, so giving a map from Rn to Rn, we can put F, map F, by the way, we can put F into the following categories. Okay, we say F is of a class C0 if F is continuous. Okay, we say F is of class C1 if F is continuous, and when you differentiate once, when you do the derivative once, the result of the differentiation is still continuous. Okay, likewise, we can generalize this. We say F is of a CK where K is greater or equals to 1. If for any K, I mean, for any K, if you F is continuous, and when differentiated K times, the result of the differentiation is still continuous. Okay, and likewise, we say F is of a sorry, C infinite class if F is continuous, and when differentiated infinitely many times, no matter how many times you do it, the result of the differentiation is still continuous. Another name for this is smooth map. We say F is a smooth map. This is very important because the C infinite maps, or in this case, let's call them smooth maps, are very important because they are the ones that will lead us, obviously, to the notion of smooth manifolds. And at the same time, and also the structure preserving maps that are between smooth manifolds. In this case, they are called diffeomorphisms. We will know what diffeomorphisms are in the next two sessions or so. So it's really very important that those of you who are comfortable with calculus, or at least those of you who have time, extra time. This is one of the reasons I avoided putting paracompactness in this thing. So you have extra time to go and revise some past undergrad stuff to make it easy for you. This doesn't mean that you might be able to work in the abstract, understand the theory of smooth manifolds, but when it comes to actually doing concrete stuff, you will struggle because you will need to understand this in a much more deeper manner in order to be able to do stuff. You might be able to understand it abstractly. I mean, understand what's being said, but it really helps if you know this, and also how to work with them. So for that, actually, because I wasn't planning to talk about this today. It was just last minute thing that showed up in mind, so I couldn't really research much references to recommend you in terms of study material in this thing. But I found this. I think this might be a very interesting thing for those of you who want to revise. It's called multivariable calculus. This is free. I have a URL somewhere that I'll put on the thing, upload to GitHub. You can also Google this and Google the author. You will see it. You will see, and I believe it's in the section 4.6 where he covers higher order derivatives. Okay, so this can provide a good source of reviewing. I hope I'm still with you. Am I still with you? Yeah. Okay. Yeah. So this is the thing that I recommend. This is it's free to download if you Google this and Google his name. I will also put the reference to where to download it from. And another one, the more classical one, is Serge Lang. This is called Calculus of Several Variables and these things. Also in this section, I believe chapter 5 and these things, you can also. This is obviously because it's Springer. It's you have to buy it. But if you Google well, there is a place. There are some places where you can get this for free, because this is already like a classic book, really, on this topic. So yeah, so these are the ones that come to my mind. If anybody, any of you, have any other resources that you think can help others revise, the notions of calculus that we need, please share it on the thing on Discord, so others can go and read. Okay, so for this section, these are the three books in terms of the manifold stuff that I recommend. Let's see how the level of difficulty is for you guys to digest this stuff, because this is already like a graduate level stuff. So it's let's see how the level of difficulty will be for you. Maybe if they are finding it you are finding it too hard, maybe I can find some other stuff. But this one, Introduction to Topological Manifolds, this should be okay. You will see a lot of examples and these things, a lot of narrative and so on. This one, An Introduction to Manifold, this one is a little bit very similar to this, yeah, but the styles are different. Maybe this one has a little bit, in some places, this one has more clarity than the other. Like, this one is a little bit more harder. So for start, I would recommend you jumping between these two. It might be that you found that this one is much more clear to you than this one, but at least you have the choice which one to go. This one also has an intro to topological manifolds before they jump into smooth manifolds. So you can also dive, back and forth to see which one, obviously cross-reference with the stuff that I gave you in order to make it easy for you. Okay. I hope you're still with me. This is the favorite, the question of the thing of the week. I hope you're still with me. Yeah. Okay. Good. This is already on the GitHub, or I believe there's the time to download it. If you haven't downloaded this one, I'm not sure, but these two definitely, yeah. So, but again, with this one, if you Google a little, the thing, you will see a free version of this. You can download it. Okay. So, and another thing is, the session obviously will be. I will cut them in small, especially with the disruption and these things. It's really helpful if I split the sessions, so you can go back again and watch the parts that you are struggling with. So they will be uploaded to YouTube. And for those of you who haven't joined us yet on Discord, I really recommend that you join the Discord so you can connect with others, especially the study sessions. I know George has been doing great by George and Amir, by trying to keep up the regular schedule on like study groups and these things. So it's really handy to have someone else you can bounce back ideas or clarify with, because studying these things on your own is not easy, especially if you are if this thing is new to you. Okay. Another thing is, please follow us on Twitter and LinkedIn and this type of stuff. If you like, obviously you are not forced to do it, but it obviously it helps, because we often put community updates, other stuff, other initiatives on there, so you can catch up. And it's also a way of knowing that we are adding value into some the thing by building a community and this type of stuff. Okay, so now let's do the poll. Okay, so thank you, George. He put another one on calculus on manifolds. Yes, thank you, George. Thank you. I will also add this, by the way. Let me copy this. I will copy. Oh, you put it on Discord. I will get it from Discord anyway, and then add it on the thing, on the reference for people to download together with the other books. Okay, so now I would like to do the poll whether you want 2 weeks gap or 3 weeks gap. Let me see. I hope. Okay, I forgot the thing, so I have to write the poll again. When would you, just bear with me, please. When would you, the next lecture to be? Think well. If you really need, as I said, I'm not the thing. The most important is to give you enough time to to wrap your head around the stuff that we covered today. Because if you struggle with this, you will definitely struggle with as we go along. Because we will add in more extra stuff. So let's see. So today is the 1st. So I guess the options are: do you want October the 15th or October the 22nd? October 15. I hope I got it right anyway. October the 22nd. Okay, so the poll is out. So when do you want the next session? You want it to be in October the 15th or October the 22nd? If you think you will have enough wrapped around your head, to proceed, then, we can do it. Please vote. Okay, let's give it a second. And then I have the joke ready to go. Let's see if I can share the screen with you with the joke. I'll share the URL for those who are not. If you're not able to let's try first. Yeah, so it seems most is that have everyone voted. Okay, so it seems most people want October the 15th. So in 2 weeks. Okay, let's do that then. So I will see you in 2 weeks. Don't leave yet. Let me share this with you. I will stop sharing first. And then share again. Let's see. I hope you can hear the sound. Can you hear the sound? So I wrote, well, the animation is not done by me, but let's see. Can you hear?
The Earth is flat.
There's the URL.
The Earth is flat.
I think you mean the surface of the Earth is locally flat. In other words, locally the Earth looks like the Euclidean plane.
Euclidean what? Euclidean what?
I could have been more precise if you knew something about topology. For example, open sets and homeomorphisms. Perhaps you should take the quantumformalism.com's crash course on topological manifolds.
What is this now?
It's just a picture that formally highlights what I have just said about the surface of the Earth looking locally as the Euclidean plane.
Okay, so that's it. That's the joke. The thing, obviously, to appreciate it, you obviously have to understand, the stuff that we went through, right?
Structure.
So don't take it seriously. It's just an informal joke, okay? So yeah. So with that, I hope you enjoy the first session. Apologies again for the networking issues, but yeah. The place where I am at the moment is a bit the networking thing is a bit of a problem at the moment, so yeah, I'll see you next time, unless somebody has any questions. Do you have any questions? One thing I would like to mention, those of you who can stay, let's see, let me go back. Okay, here now, given the pace that we are doing the crash course, obviously we are here, so there's in theory only 3 sessions left, but I think the current pace will probably maybe wrap up the crash course sometimes in November, probably, possibly end of November, I don't know, depending. So the question is whether it worth jumping immediately into module 2, or we should just take a break, have a nice December break and these things, and then come back in January for module 2. those of you being like maybe a little bit behind, can also have time to revise and these type of things. I can also go on holiday, right? So yeah, so it's entirely up to you. At the end of the crash course, I will send a poll whether you want January and possibly February, those of you, to see when you want to start module 2. Okay, that's all I wanted to say. So George is well. I hope you enjoyed the cartoon. Yeah. So this is my debut as a script writer. Please share it if you like. Please share it on social media, just to highlight my career as a script writer for thing. Maybe you never know. Maybe Disney will hire me. So yeah. Okay, so does anyone have any questions in respect to the thing, technical or non-technical, in respect to manifolds or whatever that you didn't quite get, or we are all good? Okay, well, before I say, I disconnect, I'll just confirm. Am I still with you? Okay, good. Thank you. Thank you, George. George is offering to be a volunteer for you guys, over next week. So yeah, I really recommend that you take the opportunity and go through the baseline challenges, things like building charts, trying to understand, and also the manifolds example. Because from now on, things will start to become a little bit hard. Because we are mixing, not just now. Now we are starting to bring in the toolkits of calculus in order to be able to do something on manifolds. Because as you will see, we cannot do things directly on the manifolds, but because of this thing of being able to map parts of the manifolds into Rn, it means we can use all the available tools that are available to us in terms of calculus and doing stuff on Rn, which is things that we can do, enables us to do that on manifolds, so by proxy. So it's very important that you wrap up around this. Yeah, it's very important. Yeah. Okay, so in that case, I won't take much of your time. I know we are running 10 minutes over. So yeah, it's been a pleasure again to be with all you, and I hope we catch up again in 2 weeks' time. So with that, have a good weekend, and yeah, I'll see you. Okay, bye for now.